Hello everyone, welcome to Tech with Machines. Our today's topic is quick, short, and interesting. It's specifically for beginners who are starting with cloud native applications because there are certain general terms which you should know before you begin in developing applications for cloud based environments. It's very important to learn the terms and the technology behind that ecosystem, and there are very specific terms which you would be dealing whether you are a software engineer working with the Devops closely, or you are a beginner in Devops itself. So let's try to understand those quick terms, and I think you would have already understood what I meant. So we are going to discuss about the key differences between Docker, containers, pods, and Kubernetes, and specifically how they are they signify or what is their meaning in terms or in context of DevOps and cloud native applications. We're gonna go in the order of containers, Docker, Kubernetes, and pods relatively, because that's the order in which you should actually know about them. And again, this is also one of the basic questions which are being asked in today's interviews. Specifically, most of the companies now deal with cloud native applications. So let's start with containers. So containers are more like the packaged units or packaged units of softwares. They actually package your whole code and their dependencies, so that you don't need to basically run behind the dependencies or deploy them separately. So basically you are basically packaging them together so that the application can run quickly and can run in multiple computing environments. So main key features of containerization is, or containers, is that they ensure that it's isolated. That means they don't impact or affect other systems or any other application which might be running in the same on the same machine. Second is they are lightweight because they share the host system's kernel or operating system, making them more efficient and less resource intensive comparative to virtual machines. And they can run on any system. They are portable. They can run on any system that supports containerization or that supports container runtime, like such as Docker. So that's going to be our second topic. What does really Docker mean? So understanding first container is important to understand Docker. So let's start now with Docker. Docker is generally a platform or a tool that allows you to create containerized applications, which is what we understood in our previous slide, that what does containerization mean, and Docker is the tool that helps us to create that containerization, or that helps to manage or build and deploy those containerized applications. So the key features of Docker are that containerization, it does enable the creation and use of containers, which means includes or packages the codes, runtimes, dependencies, including tools and settings. Second is images. Docker containers are built with Docker images, which are templates with instructions to create containers. Specifically, you would have heard about creating a Docker YAML, which basically have the steps to create the images. Finally, there is Docker Engine and Hub. Docker Engine is the core of Docker, which actually runs and manages the containers, whereas Docker Hub is a centralized repository where you actually store and share your Docker images. That's all about Docker. Now let's quickly understand what Kubernetes is, and then followed by pods. Let's start with Kubernetes. Kubernetes is generally termed as K8. It's nothing but the characters behind the Kubernetes, which is termed as K8. So it's basically an open source orchestration platform which actually is managing the deployment, scaling, replication, self-healing of containerized applications. It actually manages the whole life cycle automatically of containerized applications. So quickly, the key features, generally you will see that it manages the clusters of containers and it ensures that they are properly distributed, have a efficient resource utilization, can smoothly run, and can recover from failures. That's why there comes self-healing and scalability. So basically they can restart, replace, or kill the non-responsive containers, and they can automatically scale based on horizontal pod scaling, which is called HPA in Kubernetes, and we will also read about those terms when we go through the Kubernetes architecture. So automatically they scale based on the load and demand. Then there is service discovery and load balancing, which means that they distribute traffic across the containers and they automatically expose containers to network. Finally, we are going to go with pods. So pods are generally a smallest deployable unit in Kubernetes cluster, which can contain single or multi-containerized applications. Specifically, what happens in pod is that they have a shared context. They share the network, they share the same storage volume, and they can communicate over local host itself. Again, the pods are assigned a single IP, which means they have a unique IP address to communicate across each other. And the pods can be created, destroyed, or replicated, which means scaled by the Kubernetes. So these are the essentials of the cloud native ecosystem. And I hope you liked the video. And if you did, please remember to like and subscribe. Thank you so much. Have a nice day.